right, this is solving part 2, solving logarithmic equations part 2. Okay, what I want you to notice in these problems is that one part of this is not a log. One part of this is not a log. Okay, and what we're going to end up doing is using the definition of a logarithm to rewrite it. Right. So remember here, this is the logarithmic equation, but it can be written as an exponential equation. All right. Except I'm going to follow this format, a equals b to the x. Basically, I just switch the left and right side. All right, so here we go. So first of all, we need to rewrite it as one log. It is subtraction, so we write it as a fraction. So it's log base 2 of x plus 4 over 9 equals 1. All right, and now what we're going to do is use the definition of log. So I'm just going to write x plus 4 over 9, and it's 2 to the first power. 2 to the first power. 2 to the first power is the same as 2. And now, all you're going to do is multiply 9 and 2. So you get x plus 4 equals 18. Subtract 4 from both sides, and you get x equals 14. And you can check your answer, plug it in. 14 plus 4 is 18. Now, you don't have to go all the way to the end to make sure it works. You just got to make sure it's positive and not 0. 14 plus 4 is positive 18. So that's acceptable. All right, that's it. Let's go on to B. So here it's subtraction again, so that means it's division. So it's log 4 of 2x squared over 8 equals 1. Okay, and I'm going to go ahead and reduce that. 2x squared over 8 is x squared over 4, right? 2 goes into 2 and 2 goes into 8. And I am writing this without the logs by using the definition of log. So it's 4 to the first power. So 4. All right, now multiply. So x squared, 4 times 4 is 16. Let's go ahead and take the square root of both sides. So x equals plus or minus 4, right? I took the square root of both sides. Taking the square root of both sides, right? And check the plus or minus 4. If you plug in positive 4, you plugging it into an x squared, so that's positive. And if you plug in negative 4, it's positive, so that's okay. So that's it. Going on to C. Right, again, I got 2 logs over here, so I got to combine them into 1. This time it's addition, so that means you're going to multiply the arguments. So it's going to be log base 3. 6 times x is 6x, and 6 times 9 is 54. And just copy the equal 3. So I'm going to say 6x minus 54 equals, I'm going to take the base, which is 3, and raise it to this power. So it's 3 to the third. And 3 to the third is 27. So I'm going to add 54 to both sides. It's going to give me 6x equals 81. Okay, 6x equals 81 divided by 6. It's going to give me 27 halves. Right? Basically, I just reduced that fraction. Right? I can divide the numerator by 3 and the denominator by 3. 27 halves is about 13.5. Plug in 13.5. 13.5 minus 9 is a positive number. I don't really care what the actual value is. It's positive, so that's it. All right, continuing. So here I got x times x minus 3. So it's log base 2 of x squared minus 3x equals 5. Oops, this is a typo. That's supposed to be a 4, not a 3. So this is a typo. I'm just changing the problem. It should be a 4, not a 3. So this becomes x squared minus 4x equals 2 to the 5th power. So that's 2 to the 5th, which is 32. All right, this time I have exponents, so I got to move everything to the left, or at least to one side. So I'm going to move the 32 from the right to the left, so it's minus 32, and that's going to be equal to 0. Factor this, so it's x minus 8, and x plus 4 equals 0. All right, so that means x equals 8, and x equals negative 4. If you plug in 8, that'll be 8, and that'll be 8 minus 4, so that's good. 8 works. If you plug in negative 4, I got a negative value for x, so negative value for the argument, rather. So I reject this one. So the only answer is x equals 8. All right, and E. Again, it's addition, so I'm going to multiply the arguments. So it's going to be log base 6 of 3x squared minus 27 equals 3. Okay, so I multiply 3 times x squared is 3x squared. 3 times 9 is 27. All right, now use the definition of log. So it's 6 to the third, which is 216. Okay, so I'm going to add 27 to both sides. So add 27, add 27. So the 3x squared equals 243. Okay, now divide by 3. So I got x squared equals 81. Take the square root of both sides, so it's x equals plus or minus 9. All right, take the square root of both sides. All right, so I'll plug in a negative 9. Okay, that'll be 81 minus 9, so that's okay. Plug in a positive 9. It's still 81 minus 9. Right, so I'm plugging it in up here. Plug in the positive 9, get 81 minus 9. Plug in the negative 9, and you get 81 minus 9. So that works. That both work. And this is not the last example, believe it or not, because I'm going to do some from your homework. So this is log base 5 of x squared minus 8 over 4 equals 2. Right? It was subtraction, so I rewrote it as a fraction. Right? If you have a one log minus another log, you can write the arguments as a fraction. Okay? Now we do x squared minus 8 over 4 equals 5 to the second power. All right? 5 to the second power is 25. So now we just multiply. Right? This is a 4. So I multiply 4 times 25, that's 100. So it's x squared minus 8 equals 100. Add 8 to both sides, and I get x squared equals 108. Take the square root of both sides, I get x equals plus or minus square root of 108, which is plus or minus 6 root 3. All right, a little reminder of how to get that plus or minus 6 root 3. You take 108, you factorize it. 108 is 2 times 54, 2 times 27, 3 times 9, 3 times 3. So there's a pair of 2's and a pair of 3's, right? So 2 comes out, 3 comes out. You have a leftover 3, so that's square root of 3. So the 2 times 3 is 6, and that's why it's plus or minus 6 root 3. And when you plug it in, right, you plug it into an x squared, so it doesn't matter what the sign is, because if you square something, it's going to be positive. And 6 squared is 36. I know it's not 6, it's 6 root 3. So it still ends up being bigger than 8. That's the point, right? If I plugged in 1, then it would not be big enough. But I'm plugging in 6 root 3. Okay? All right, so I'm going to do a couple examples from the homework. Okay, because it's a little different. So the first couple problems are a little different, but it's still the basic idea. So I have a 9 out here. So I got to get rid of this 9, right? It's 9 times the log. To get rid of 9 that's being multiplied with log, you divide by it. So what I got is log base 3 of negative 10x equals 1. So this is going to be negative 10x equals 3 to the first power, which is 1. Divide by negative 10. You get x equals negative 3/10. And that's it. Okay, and I'm going to jump down to number 5. Oh, wait. Let's check this answer. I forgot to check the answer. You plug in negative 3/10 into negative 10x. So the negative 10 times negative 3/10 turns positive. So that's good. That's all you need. That's all you're checking for, making sure when you plug that value in, you get a positive argument for the log, and it does. All right, let's jump to number 5. Okay. All right, here we go. So you're going to add 8 to both sides. Add 8, add 8. So that's going to be log base 3 of 5b minus 10 equals negative 1. So you're going to say 5b minus 10 equals 3 to the negative 1. Well, 3 to the negative 1 is 1/3. Don't forget that, right? So you're going to add 10 to both sides. So it'll be 5b equals 31/3. All right, if you don't know how to add fractions, go look it up. All right, divide by 5. So dividing by 5 is the same as multiplying by 1/5. So b equals 31/15. Okay, I'm going to plug that in. 31/15 times 5 is 31/3. 31/3 is 10 1/3. So it's still bigger than 10. So that's going to be positive. So that's good. All right, and I'm going to do number 10. I'm doing number 10. Number 10, I'm going to get rid of the 6 first. You always get rid of addition before multiplication. So I'm going to get rid of the plus 6. So that's going to be negative 9 log 11 of 5. Sorry, negative 5 and minus 4. So 6 minus 6 is 0, so that's 0. Divide by negative 9, log 11, negative 5n minus 4. When I divide 0 by negative 9, it's still just 0. Now I do negative 5n minus 4, okay? And it's 11 to the 0 power. Anything to the 0 power is 1. So it's just that. So I want to add 5 to both sides. So it's add 4 to both sides. That's going to turn into 5. Divide by negative 5, and I get n equals negative 1. N equals negative 1, plug it in. Negative 5 times negative 1 is positive 5. Positive 5 minus 4 is 1. So it's positive 1 when I plug in negative 1. So that works. All right, that's it. Have a good night.